This first example here is a really common example on the last 3 Regents exams, and basically it's just saying that cosine and sine are equal as long as the angles are complementary. So that's this whole theorem, and that's what this whole page is about, is that sine and cosine are equal whenever the two angles add up to 90. So basically, kind of an application of this would be sine of 40 degrees would have to equal cosine of 50, because 40 plus 50 gives me 90, so sine and cosine of those are equal. Now, the reason for that is kind of explained here. So basically, in this situation, x and 90 minus x would represent two angles that have to be complementary, because if you add x plus 90 minus x, you're going to get 90. So since those add up to 90, well, then the third angle in the triangle would have to be a 90-degree angle, because 180 minus 90 would give you 90. So this situation is saying that if this was x and this was 90 minus x, those are complementary, and then you have a right triangle. And then when you look at this picture over here, the reason why sine and cosine of complementary equals are equal is because if I'm looking at finding angle, like let's say sine of angle A. Well, sine of angle A is the opposite over the hypotenuse, and if you look at angle A, the opposite of angle A is the adjacent of angle B. So since the only difference between sine and cosine is one is opposite over hypotenuse and the other is adjacent over hypotenuse, if I'm looking at the opposite of one angle, one of the acute angles, then it's the adjacent of the other acute angle, or the complement of it. So same thing goes for angle B. So if I'm looking at angle B, the opposite of angle B is the adjacent of angle A. So if I'm trying to find sine of angle B, well, that would be the opposite over the hypotenuse, which is really cosine of A, because cosine of A is the adjacent over the hypotenuse. So that's why this is working. The next example here, I already started kind of with the reasoning. It says, in right triangle ABC with the right angle at C, sine of A is 2x plus 0.1, and cosine B is 4x minus 0.7. Determine and state the value of x and explain your answer. Well, the first thing here is the description, that if triangle ABC is a right triangle with right angle C, that means that those other two angles, A and B, have to be complementary. So basically, if you have this situation where I have a right triangle and it says that this is angle C, well, then A and B have to add up to 90, because if you do 180 minus this 90-degree angle, well, you're left with these two angles having to add up to 90, because there's only 90 degrees left to split between them. So then, since they're complementary, that means sine of one of them has to equal cosine of the other, which really means, so since the sum of those angles is 90, that tells us that sine of A would have to be cosine of B, as well as sine of B would equal cosine of A. So the sine of one equals the cosine of the other. So if we're looking at this, what they give us here, they're telling us that sine of A is 2x plus 0.1. So instead of writing sine of A here, I'm going to write 2x plus 0.1. And instead of cosine of B, well, that equals 4x minus 0.7. So I can just set them equal. I'm just plugging in. So then from here, you're just going to solve it like a normal equation. So I'm going to just subtract 2x from both sides. So we get 0.1 equals 2x minus 0.7. Add 0.7 to both sides. So we get 0.8 equals 2x. Divide by 2. So you get x equals 0.4. The next example here is a little bit different, because instead of giving you what sine of A and what cosine of B equals, they're telling you that sine of theta over 3 plus 10 is equal to cosine of theta. So if this is true, that means that these two angles must be complementary. These have to then add to 90. Because the only time that sine of something is equal to cosine of something is if they add to 90. Just like this example up here. Sine of 40 would equal cosine of 50, because 40 and 50 add to 90. I could also say sine of 45 equals cosine of 45 because they add to 90. So any situation where you can add your angles and get 90, sine of and cosine of those angles must be equal. So to solve this one, I'm going to just add them and set them equal to 90. And remember, theta is just a symbol. You could make it an X if you feel more comfortable with that. It's just a symbol we typically use in trig. So to solve this, the first thing I'm going to do is I'm going to clear the denominator. I don't want to have to deal with that 3. So what I'm going to do is multiply everything by 3 to clear it. So then those are gone. And I have theta plus 30 plus 3 theta equals 270. And then I'm going to combine my like terms. So theta plus 3 theta is going to be 4 theta plus 30 equals 270. And like I said, if the theta is confusing, make it an X, because I know it kind of makes it look like zeros here. So then I'm going to subtract 30 from both sides. So 4 theta equals 240. Divide by 4, and you're going to get theta equals 60. And again, the reason for that is because if sine of A equals cosine of B, then the measure of angle A plus the measure of angle B must be 90. They must be complementary. So that's kind of my reason for what I did there.